email to everyone, and that's why I need to talk into the computer so you can hear on the recording what I was actually saying and doing. So I'm going to start out by finding the application again for the free computer that you can get at the college. When you say, I don't need the free stuff, what for? Because it's free. Well, it's a brand new computer with a free internet. You go shopping, just how much you pay for the internet per month. Well, the college will pay for you. That's the point. So
Recording in progress.
So I wanna make sure that I mute everybody so don't have this echo. Okay, so Antelope Valley College website, when you get into it, so just click on it, right, to get to AVC website, then you can find here the menu choices for so-called quick links. And the way to go is just go to the sitemap. So you get on those links and the sitemap at the very bottom. So when you click on it at the bottom, then everything we have on this website will be in one page in alphabetic order. It's actually, I guess, more than one page. So what you need is to get the basic needs, the very first one, basic needs. And once you click on it, there's a big application and you can apply, you can even see what they have here. So last ones related to technology, and there's a Wi-Fi and hotspot. So how to get it? Well, you need to click on the application. That's the word application here. So once you click on it, you will be able to fill it. And if you do it today, I guess tomorrow, the device should be ready for you, as well as internet, because if you don't get that hotspot this week, then next week will be very unlikely because lots of students want to get a free internet. Why not? Right? So think about it. Anyways, going to also show you the free textbook again, how I found it. Important way to do is go to Google. Some people say, Alex, I don't like Google. I prefer dark web or something. Well, it's not there. Just go to Google, type Sullivan pre-calculus. Sullivan is the author of the textbook and the pre-calculus. And then don't forget about PDF. And then you can click on that first choice and get yourself a free textbook. So that's why I do it in this online mode, so we can nicely utilize everything that you otherwise would have to purchase. And if you remember last time, we tried real hard, and a student was also tried to help me with this screen and projector, and it just doesn't work. So if I get that book online, I can't really project it anywhere. That's why here on Zoom, with a recording, you also get a free textbook because you get this recording plus problems that I solved and sections that covered in a class. So make sure you get this free textbook, download it. Again, if you're only on a cell phone, I'm not sure if you'll be able to do that to the cell phone, maybe, but I'm not sure. So you need to be on the computer, some kind of desktop, laptop, notebook, whatever, so it has enough memory so you can download it to your hard drive, because it may disappear. And if it disappears, well, we'll find another textbook for you, but it's not hard. It's just pre-calculus PDF, and there'll be tons of them. But thing is that it's convenient to use the same book, right? And that's why I highly recommend that you download it right now if you didn't do it. And if you don't remember if you did it or not, if you downloaded already, Well, download it again. It'll tell you, oh, it's already here. So it's not a big deal. You can always delete it later. But if you plan to take a calculus class after pre-calculus, you definitely need to be very familiar with pre-calculus. So you should have a textbook, right? Because electronic versions, they after semester disappear, even if you buy it, but it will go away. Your link is not going to work. And that's why it's very good to have a free textbook, which is going to be with you as long as you have that computer or wherever you download it. You can do it on a thumb drive, for example. It's not big. PDF files are not very big. So anyways, let us start talking about the pre-calculus, or actually trigonometry. And again, I emailed a recording of previous lecture, which I think is probably the most important lecture because it talks about the class and all the settings and everything, and tests that you will be able to get in online format. I will just email them to you. And that's why I actually cannot run class in a classroom if I give online tests. So if you're here, you like to be here, I'll give you tests here. And probably it's not a very good idea because the results usually are not as good as practice shows if you take the test supervised. And I will just email you those tests, give you whole day for it, and I'm not going to make you being watched by someone. So you will do your best and get the best possible grade. So I think that's a fair deal, right? So anyways, let us start, and I will go to the middle of the textbook because trigonometry starts at chapter 6. You say, what about chapter 5, 4? Well, that's a college algebra. It's a math 128. If you didn't take it, well, you can take it or just look at the textbook and see what's in there. But trigonometry you will heavily use when take calculus. So this textbook is awesome because you don't have to browse through the pages. You just go to the contents, click on first section of chapter 6, and you get right away to where you need. So I guess it's very convenient, right? So I guess I'm going to make it a little bit bigger and see what this first section of chapter 6 is talking about. And this is all about angles. So we're going to have nice vocabulary that deals with story about the angles. And I'm going to be today discussing angles in terms of degrees. Turns out there are two ways to treat angles: using degrees or using radians. So about radians, I'm going to talk next time. So it turns out that if you rotate all the way around, that's called 360 degrees. Don't ask me why 360, why not 366 or 200? It just happened to be 360, so that's how it's being defined. And then with respect to 360 degrees or so-called full rotation, you could get half of it, and half of 360 is 180, right, degrees. Or if you break that 180 by another two pieces, that will be 90 degrees, and people like to put a little square to make sure that everybody knows that this is 90. So it's sometimes called right angle. And there are various other angles with respect to this you can produce. And the most popular ones that we're going to be working with is 1/3 of 90, which is 30 degrees, or twice that will be 60 degrees, and so forth. So that's how we determine those angles with their measures, and they all come out from the full rotation. So it's just parts. Yes, there are fractional parts of degrees as well, so you will see it, but it's not as popular later in the exercises. I would say most populars are 30, 60, 90, and 45. And then there are various others with respect to those, because there could be an angle, for example, measured 135. So it'll be something like that, in 135 degrees. So it's like 45, which is a half of right angle, and then another 45, and then 135. So that'd be 3 of those 45 degrees, 45 degrees. So we get all kinds of angles. Turns out that it's important to know where the angle starts and where it ends, and those are so-called initial and terminal sides. So that's a little bit of a vocabulary. So they nicely showed here in the picture. So if you start with this horizontal, like x-axis direction, and then rotate, I want to say, what did they do here? Because it looks like they rotated more than all the way around. It's a little extra, right? Looks like it could be 360 plus something. So yes, angle could be more than 360, so you could rotate as many times as you like, turns out, and end up with the angle that might look like a little one, but actually it has so many rotations in it already, so its size could be definitely more than 360. So the message is, in mathematics, anything is pretty much possible. So here's the other interesting observation, that if you rotate counterclockwise, so let's say if that's 135 degrees, then the measure of angle next to it that we produce rotating clockwise will be negative. How about that? When you say, really, how is it possible to have a negative angle? Well, it looks like if you started again at the initial side, but went kind of downwards, so that angle will be like a negative 135. It's pretty odd, right? Well, actually, there are negative numbers, there are negative angles. It's just when you go clockwise, we put minus in front. So it turns out that it's important to have the clear understanding of what angle you were actually producing, because if you just put it like that, then one can say, oh, looks like that's like 100-something degrees, but somebody else can say, no, Alex, I think this is negative angle, because you could have also produced it rotating the opposite way, right? Or you could have rotated a few times and end up at that same so-called terminal side. So you get various possibilities, even though the picture may look the same, and that's the reason why it is important to put this little angle so people know how we actually, where we started and where we ended, and if we rotated more than once or less, or clockwise or counterclockwise. So on the same picture, there could be hidden more than one angle, in fact, infinitely many. You could have produced the same end and side rotating clockwise or counterclockwise or lots of times and so forth. And that makes it not being unique, because we used to produce points on X and Y plane with only X and Y coordinates, just two of them. But now you could rotate way more than once, and that's going to give you a lot of possibilities from the same picture. some messages. If you took college algebra, every point on the plane was given you unique pair of coordinates. But with this angular presentation, it's not unique because if you rotate more or the other way around, it'd be different angle for it. And that's why one gets a little bit extra in this class compared to the previous math classes. So they talk here about the angles and drawing various angles. And I guess what we're gonna do for the homework, and somebody emailed me about the homework, and that's great. It means that you really care about doing the homework, right? So I really love emails related to homework, so that's why I wanna answer it right now as well. So I'm going to be covering sections of chapter 6, 7, and 8, and so forth. So whatever I do in class, that's what you should look at. If I didn't do something in class, don't worry about it. Unless you really want to learn it yourself for whatever reason, just because it is in the textbook. I would say the textbooks, they usually have more information than we need for the class. So they always put some extra sections, some extra stuff. That's why I will be skipping something. But if you want to read it and do something, if you have nothing else to do or just interested, that's fine. You can do that. And you can also ask me questions. Since I provided you with this book, I will be doing my best to answer any questions from this textbook. When you say even from college algebra, yes, sure, why not? I'm glad that you're curious. If you didn't take that class or it was a while or you forgot, well, then you can ask me questions related to college algebra as well, which is first 5 sections of this textbook. So anyways, when you get to the end of the section, there are various exercises. So what to do for the homework? First of all, I don't ask you to worry about this. Are you prepared? And vocabulary. Actually, vocabulary is what I'm talking about during the lectures, all these degrees and angles. So that's what you will see anyways. But what you need to do is problems from so-called skill building set of exercises. And that's what I am also going to do. So I'm going to look at the sections end every time in class and do a few problems from skill building exercises. If you tell me, Alex, how about doing problem, let's say 44, whatever, well, then, of course, I will do it for you. But besides that, I will be also selecting problems that I think are very good to learn before you take calculus, or in general, if you are taking the trigonometry class. So I will be selecting the most important exercises. So that's why if somebody does learning on her or his own, then of course you can read in advance because you have a textbook and do some problems, but still look at the recordings of lectures that I will be emailing to you after the class every time, because that way it helps you to concentrate on what you really need for this class. Because if you start to read book, you will have like 2 or even 3 times more material than you need to take out of this trigonometry class. Because my goal is to prepare you for taking calculus, because it's all based on trigonometry story. So anyways, looks like here they have various angles, and since I'm going to be talking about the degrees and everything today, so I'm going to try to do a conversion. So it turns out that if you have 1 degree angle, so that'd be very, very small, right? So I can extend it a little bit. So it's 1 degree measured. Then you can break it into 60 pieces, and 1 degree will be the same as 60 minutes. Or if you divide both sides of this little equation by 60, then 1 minute will be 1/60 part of degree. So you can, let me see, what is this? It's kind of hard to see, it's degree. So 1/60 of degree. So that's the way you can convert degrees to minutes and back. So for example, if somebody is going to do problem number 29 here, and we can take a look at the 40.32 degrees. They say, how many minutes here? Well, I need to know that if one degree is 60 minutes, so how can I produce minutes from 0.32 degrees? Well, I guess I can say that 0.32 times 1 degree, right, is going to be, that's what we have here. We already know it's 40 degrees, but what's about 0.32? Well, I need to rewrite that 1 degree as a 60 minutes, so it'll be 0.32 times 60. And when you multiply, and to multiply this, you definitely want to use a calculator. It's kind of going to be annoying without it. So here's a free calculator for you called Scientific Calculator. Start typing and it appears, Scientific Calculator. And here's choice number 1 that I take. So I multiply, I will utilize this calculator for all in class demonstrations because I think it's very nice calculator, not just because it's free, but because it is very indeed convenient to use. So 19.2 minutes. So instead of doing this as a 40 degrees, you can say it's a 40 degrees and 19.2 minutes. See? So those are little tiny pieces. And again, it's 19 minutes, but turns out, what about 0.2? And if you recall how this exercise was originally set up, they asked not just about degrees, minutes, but they also use seconds. And if 1 degree has 60 minutes, then how many seconds in 1 minute? Well, it's 60 seconds, right? So they call them like that with 2 little primes, 60 seconds. So looks like, again, this 19.2 minutes, I can write as 19.2 times 1 minute. I say, well, that's kind of cheap trick, just multiply by 1. Well, but then turns 1 minute into 60 seconds, and that's just what I need, you see? So multiply this by 60 of those little seconds. And then we have, again, the calculator to use. So I'm going to go back to it, and I can share this link to the calculator right now in the Zoom. If you're on Zoom, you can actually get this from the chat. I'm sending it right now to everyone, so you can just click on it, on this calculator, and bookmark this page. It'd be convenient for you to have this among bookmarks, so you'll be able to always get this without typing scientific calculator, whatever. So let us see how many seconds we actually have here. So I'm going to go ahead and put 19.2 times 60. And, oh, I don't need 19. I just need 0.2. Sorry, I already have 19 minutes. Yes, it is so many seconds, but I don't want to write it in terms of seconds. I want to n minutes, n seconds. So I already have 19 minutes, right? So I better put this down. So 19 minutes is already here. So I just caring about 0.2 times 60. So I don't want to turn minutes to seconds. I just want to turn 0.2 to seconds, right? So it'll be just, we work with decimals. So 0.2 times 60. So let us do that. See, I got carried away. I got so excited about this favorite calculator of mine. I guess I should take it easy. So 12, right? 12 of those seconds. So I guess that's the way to go. And well, having ability to get the free textbook and free calculator reminds me when I was a student back years in the Ukraine, where, well, I had to copy everything that professor would write on the board. And even if I didn't understand, I would just had to copy and then read it later to start understanding what was going on. Because if you didn't copy before it's erased, because the board is not very big, so it just writes, erases, it's all gone, so you didn't have time. And I know that when you are in class, yeah, attention may go someplace else for a few seconds and you lose the point. And that's why I think having the recording of this is so awesome. I wish I had such a opportunity not to copy lectures, but to get all of the notes of the instructor. And that way is definitely kind of more productive time when you're on the lecture, right? Instead of just copying from the board. So anyways, it looks like we are ready to put our answer down. So what is the answer? So it looks like this is 40 degrees still. Now we saw there is a 19 minutes, right? So I put this 1 prime with it. And we also found out there are 12 seconds. 12 and 2 primes next to it. So this is our answer. So it looks like here we have the exercises of that type. And I did it slowly, but turns out if you try another one like that, it'll be the same thing. So I can do one more of these conversions. I know you probably never saw this before. Well, at least you're familiar with minutes and seconds, right? So it's 60s parts. So I can try, let's say, last one, 44.01. So how can I do that? Number 34. Well, you do this exact same way. So you already know you have 44 degrees. So now what about this 0.01? Well, first you're multiplying it by 60 and you get minutes. That's what I actually did here. I just did it a little bit slower because I tried to explain why we do this. But turns out the exercise is pretty much straightforward. So if you go to the tutor, they'll just take, oh, multiply it. And it's so fast and so obvious. But the reason why is because you say actually take it times 1 degree, and instead of 1 degree, you put 60 minutes, right? And then you put times 60 and you get 0.6. I hope you can see it here. Let me clear that little messy part. 0.6. So it is not really minutes, right? Because it's 0.6 of minute. So whole part of minutes is actually 0, right? 0.6. It's time to go? Not yet. Okay. And then we turn this 0.6 part into 60 times 60 seconds. So we turn this into seconds, right? And I say, Alex, I can do this. 6 times 6 is just 36 without calculator. Okay. Or you can check it with a calculator. If 6 times 6 is 36. Notice that 0 kills that 1 decimal, right? So it's 36 seconds. So I ended up with 44 degrees and 36 seconds. And 0 minutes, so we don't put anything. Or if you want to put 0 minutes, it's up to you. In fact, when you do your homework, first of all, I recommend you to do exactly the same problems that I do in class. The reason is you can do them right. And I think it's always a good idea to redo the same exercises. So you could just do exact same problems on a piece of paper. And when the midterm day comes, well, send me all of your work by email, and that be your homework because you do it at home, right? It's outside of class work called homework. So I wouldn't really care what exactly problems you do. I say, Alex, no, I want to do 31. I like it, looks good, it's 2-5. Okay, do 31, do whatever you like. I know it sounds kind of unusual, so Alex does not assign homework. I do. I tell you, you select what you want to do. Because some people may like to do word problems. Some people may not like word problems. I'm not going to make you do any word problems for homework. But again, do whatever problems you like. Or do those that you don't like. It is up to you. You want to challenge, take more difficult exercise. You want to just get a good grade with that in this class. Well, just do whatever I did, because that's the best for concentration. And how many problems? A few problems in each section will be good enough, because I think the exercise 29 and the exercise I just did is pretty much same thing. It's just different numbers. You multiply by 60 and then by 60 again. So what difference does it make if you have a calculator, what numbers you plug in? And that's why I never ask my students to do tons of exercises, because if you already know how to do one, then you know pretty much how to do everything in this group of problems. So instead of wasting your time, you better move on. That's why I'm saying a few problems from the lecture, the same or analogous, will be good enough. Let me do problem number 23 to do the backward conversion. So what does that mean? Well, now they give us degrees, minutes, and seconds, and they want us to write it as a decimal. You see, what for? We just had decimals and we wrote them like that, and now backwards? Well, yes, to just get used to it. That's why, again, if you can do one, then everything else will be the same. So if you have here is 40 degrees and 10 of those minutes and 25 of seconds, then remember, then 1 minute is a degree divided by 360. Oh, by 60, sorry, right? And 1 second is 1 minute divided by 60, right? Because there are 60 seconds in a minute. But if you turn this into, it's 1 minute, I should be careful. I was not careful. I should put this prime instead of degree, because I want to turn this now into degree, right? Because they told me write everything in terms of degrees. So how can you do this? That's 1/60 of minute. But again, instead of 1 minute, I can use 1/60 of degree. So it'll be 1/60 divided by another 60. So if you divide 1/60 by another 60, you'll put 60 in denominator. So it'll be 36 with 2 zeros of degree. So if I have such a number, then instead of 10 minutes, I write 10 60s, because instead of minutes, I put 60s. And instead of 25 seconds, I put 25 36 hundredths, you see? And there's still 40. So of course I put plus and a plus. And again, that's a pure calculator exercise. I think it's a real waste of time. Say, no, Alex, I can do this by hand, and let's divide 1 by 6 and so forth, and 25 by 360. I don't think there is a point. It's really better, instead of enjoying this arithmetic, do something else. So I just entered this in the calculator, directly and get the result 36 with 2 zeros. And here it is, decimal, they win it. So it's something like 40.1736 ... So I was thinking about giving you a little quiz analogous to this one. So let me try another exercise, and then I'll have you try one. So you're going to need a calculator, and when you say, Alex, you know what? I'm blank. I just can't do this. I will send it to you by email, this recording. So over weekend, you can do it when you wake up sometime, say Saturday morning, all rested and feel like doing trig, and you can do it then and send me the answer by email. Just make sure that you tell me what this is for. Just tell me, Alex, it's trigonometry quiz. Oh, good. So I will grab the roster with trigonometry and be more than happy to give you 2 points. So it's not the end of the world. I give you plenty of time for quizzes. If you can't do it right now and put the answer in the chat, well, then you can do it later and send me the answer by email. Because point of quizzes is make sure that you keep up with the course material. It's not to downgrade you. I think quizzes is the nicest part because you get all those points. You just want to, of course, be serious about this and do something. You do nothing, and how can I give you those points? And that's why, remember, I started the class with giving A to everyone on Canvas. Did you check the Canvas? You have A for this class right now. So just keep doing things and it'll stay like that. If it, after the midterm, goes lower because you didn't do midterm, well, then do the midterm and it'll go higher. And if you don't do well on it, I will tell you what to do. See, with this online environment, I can let you retake exams or quizzes as many times as you want. And main reason why is because I have plenty of time. And it actually takes me much longer outside of class to do all this grading on daily basis and update your grades and everything. It's easier to be in a classroom and just give you some exam and leave and grade it once, not giving you a chance to redo it. And I'm fine with that. I have time. In fact, I love grading. That's why I really can help you with this. So again, those quizzes is not to give you any hard time, but to help you to learn some of the trigonometry. So anyways, let me do one more exercise and then I'll have you try to do the exercise. Let me try number 25. 1, 2, 3. How about that? So it's going to be 1 degree plus 3/60. Those minutes, they turn into degrees, they're 60s. And the last will be 3/3600, right? And I definitely need a calculator for that. I know if you don't have a calculator right now with you, you won't be able to do this, but again, you can always do it later and email me your result. So let's put this in here. So 1 plus, oh, it's 2/60. Thank you for paying attention. See, I need to concentrate. I need to say to myself, Alex, concentrate, because if I not concentrated, I will write all kinds of things here. Yeah, it was 1, 2, 3. Thank you. So 2/60, and that's very timely change. You didn't wait until I finish up with the exercise. I said, Alex, you forgot something, so redo the problem. Well, no, that's fair. So I really appreciate it. So don't hesitate whenever you see that I miswrote something or miscalculated or made a mistake. Let me know. I'll fix it right away. So I better be careful. So 36 with 2 zeros. So here's the decimal. I say, how many decimal points should I put? Well, put few of them. I never pick if somebody just puts 1.03 or 1.034 or ... with it, it's fine. So we got the answer. So it looks like that's what it is. So for the quiz, please use the chat. Here is the chat where I put all of the interesting informations about links in, and make sure you send it only to me. Don't send your answer to the whole class, because if you do that and if answer is not correct, then, well, the whole class would not be very happy with you, right? So just don't hurry. I give you plenty of time for this quiz. You don't need to hurry. In fact, you can send me the answer later tonight or tomorrow or whenever. So I'm gonna ask you to do the problem number 27. I think it looks pretty straightforward, right? Nice numbers. So for the quiz, you should get a calculator and produce decimal for exercise number 27, and put that decimal in the chat, and please send it only to Alex. Don't send it to everybody, okay? Because it's still a quiz. I want other students to also think about it. And once you're done with the quiz, well, you can go and enjoy the rest of the day, or if you want to stay and ask me some questions, please do so. Just one thing I need to tell. Sometimes people ask me question during the quiz and I don't answer. Well, because there might be already 15 messages in front of you. So just be a little bit patient, because that's disadvantage. Of course, when you're on the chat, I cannot see all the questions at once, all the answers and questions. So just be a little bit patient. I will get to your question, of course, but it might take a little longer if it's at the end of class. Okay. So I'm going to stop to record.